Welcome to DozoChem. This video covers solution stoichiometry. You may recall the general strategy for a stoichiometry problem, which is to convert the original unit they give you to moles of the known chemical, then use the mole ratio from the balanced equation to get to moles of the unknown chemical, and then you can switch it back to whatever unit they ask for in the problem. In solution stoichiometry, you're going to use molarity to convert to and or from moles if one or more of your reactants or products are aqueous. So I'll give you a couple of examples. In this problem, they give you the volume and molarity of Ki solution. So that's our known. And they're asking how many grams of PbI2 will be produced. So PbI2 would be our unknown. So we're going to use molarity and volume to get to moles of the known, which is Ki. So first you're going to want to take the volume in milliliters and write it down in liters. So you divide by 1,000 or move the decimal 3 places to the left. So now we take liters times molarity, but rather than writing capital M, we're going to write moles of Ki over 1 liter, so that the liters cancel. Now I have moles of Ki, then I go up to my balanced equation to find my mole ratio, and there's 1 mole of PbI2 for every 2 moles of Ki. So I just copy those numbers here, and that will cancel out moles of Ki and give me moles of PbI2, and they ask for grams, so last step is simply to multiply by the molar mass of PbI2. And that will give me my final answer in grams of PbI2. Now, let's look at an example where we're going to use molarity twice, both for the known and the unknown. One to get to moles and one to go from moles to volume. So, in this case, how many milliliters, 0.16 molar CaOH2 are needed to react with 48 milliliters of 0.36 molar HCl in the following reaction? So for HCl, that's our known. They give us the volume and molarity. And CaOH2 is our unknown, and they give us just the molarity, and they're asking for the volume. So as we did in the last slide, we're going to change the volume of our known HCl to liters by dividing by 1,000 or moving the decimal 3 places. Then we multiply by the molarity, but it's written out moles over 1 liter. Moles of HCl over 1 liter. So if I multiply liters times molarity, I now have moles of HCl, then I do what I did on the last slide, which is come up and find my mole ratio, 1 mole of CaOH2 for every 2 moles of HCl. So I copy those here. That will cancel out moles of HCl. Now I have moles of CaOH2 and I want volume, so I'm going to divide by the molarity, but I'm going to write it 0.16 moles of CaOH2 over 1 liter and then flip that upside down so that moles cancel and I get liters. But the question asks for milliliters, so last step is to multiply by 1,000, and that will give me the number of milliliters. So that's it for this video. Good luck.